Now, in the previous types that we had for limits to infinity, we use the rational function theorem. The rational function theorem is analyzing the asymptote, either the horizontal or the special slanted asymptote. So we're going to this time use limit theorems and limit properties to calculate a limit to infinity. And to do that, we're going to check out the largest degree term in the denominator, and we're going to go ahead and divide or multiply by 1 over the largest degree factor, or the largest degree term, to the numerator and denominator. And when we do that, we get the limit as x approaches negative infinity of x squared over x when we distribute 2x over x, x over x, and 3 over x. And then using our limit properties, we can rewrite this as the limit as x approaches negative infinity, and we're going to do it for each term. So again, x squared divided by x is x. We're going to go the limit as x approaches negative infinity again, and this is going to be of 2. For the denominator, the limit as x approaches negative infinity of 1, and then plus the limit as x approaches negative infinity of 3 over x. And to calculate our limit, the limit as x approaches negative infinity of x gets us negative infinity. The limit as x approaches negative infinity of 2 is simply 2, so it's minus 2. The limit as x approaches negative infinity of 1 is 1. And the limit as x approaches negative infinity of 3 over x is 0. Negative infinity, subtract 2 is negative infinity, and we'll go ahead and divide 4. By the way, this limit is not 3, this limit is 0. So this should be 0 in here. And we don't get 4 then, we get 1 in the denominator. And negative infinity divided by any constant will get us, in this case, negative infinity. So our answer is negative infinity, and that matches, of course, the one that we had originally in letter E. Now, using that concept, we're going to do the same thing here. So we're going to go ahead and multiply the numerator and the denominator by 1 over x squared as a radical, and we'll do that in the numerator as well. So the square root of 1 over x squared. So this will be the limit as x approaches infinity of the square root of 9x squared over x squared, subtract 2 over x squared, divided by the square root of x squared over x squared plus 3x over x squared, subtract 1 over x squared. If we simplify it, it's the limit as x approaches infinity of the square root of 9 minus 2 over x squared, divided by the square root of 1 plus 3 over x, subtract 1 over x squared. So the following calculations for our limit will be the limit as x approaches infinity of 9 is 9, then we take the square root and we get 3. The square root, or the limit as x approaches infinity of 2 over x squared will get us 0, and the square root of 0 is 0. The limit as x approaches infinity of 1 is 1. Take the square root, we get 1. This will get us 0, and this will also get us 0 for our limit. So our answer in this case is positive 3. We'll do the same idea for letter G. So we'll go again 1 over x squared. You don't have to multiply it by 1 over 2x squared, so we'll just leave it as 1 over x squared. So it's the limit as x approaches negative infinity. And when we simplify here, we get 5 over x, subtract 3 over x squared, divided by 2 minus 3 over x plus 1 over x squared. We're going to take the limit of each one of those terms. So the limit as x approaches negative infinity of 5 over x is 0. This one will also get us 0. 2, 0, and 0. And so our answer will be 0 over 2, which is 0. That's our limit as we approach negative infinity. If you also look at the horizontal asymptote, 5x over 2x squared also gets a horizontal asymptote of y equals 0. If we look at letter H, so H as x approaches positive infinity, we're going to multiply by 1 over x to the numerator and the denominator. So when we distribute that in, we get the limit as x approaches infinity of 2x squared over x is 2x, 5x over x is 5, 4x divided by x is 4, and 1 over x is going to stay as 1 over x. Now we'll take our limit. The limit as x approaches infinity of 2x will get us infinity minus 5 divided by 4 plus 0. So this is going to be positive infinity divided by 4, which is positive infinity for our limit. And again, you can look at that. 2x squared divided by 4x is going to get us a slanted asymptote that's going to go that direction, and because we're going to infinity, it's going to approach in an infinite direction. Letter I might be the toughest one on here, but we'll discuss this one. We're going to multiply the numerator and the denominator by 1 over the square root of x squared. So when we simplify that, we get the limit as x approaches negative infinity. And I'm going to use full limit properties because I want to show you how this is going to work and why the limit's going to come out the way it's coming out. All right, so this one right here, now here's why it's deceiving. This is 2x in the numerator. Here's why this one's deceiving. As you substitute numbers in that are negative, so as you go to negative infinity, those values are going to come out and get negative y values, not positive y values. In the denominator, if we plug in negative infinity to x squared, and negative infinity squared is positive, take the square root, and we get positive infinity. So we can just take the square root of x. So that'll get us a negative 2, and that's a negative 2 in our numerator. The denominator, everything's pretty straightforward here. This is going to get you 1. Square root of 1 is 1. And then this one's going to get us 0, so it's plus 0. That'll get us 1, and our answer is negative 2, not positive 2. Letter J, we've got one where we're going to strictly use limit properties. So this will be the limit as x approaches negative infinity of x squared. Subtract the limit as x approaches negative infinity of x to the 5th. We can also, if we want to keep using limit properties, we can use the exponent after we've taken the limit. So the limit as x approaches negative infinity of x is negative infinity, and we're going to square it, so it gets us positive infinity. Subtract the limit as x approaches negative infinity of x is a negative infinity to the power of 5. Negative infinity to the power of 5 gets us a negative, which is times a negative. We add those together, we get infinity. Letter K, we're again going to use limit properties, so we're going to multiply all the way through by 1 over x. So we get the limit as x approaches infinity of 4x squared, subtract 2 plus 1 over x, divided by 1 plus 3 over x. So the limit as we approach positive infinity, we end up getting positive infinity for that one, 4x squared. Those numbers will end up getting bigger and bigger and bigger. Here we get minus 2, and here we get 0. The limit as x approaches infinity of 1 is 1, and the limit as x approaches infinity of 3 over x is going to get us 0. And our limit in this case is going to be infinity over 1, which is positive infinity. It's a little deceiving when you start looking at asymptotes. This, when you divide them, you get 4x squared. There's no such thing as a parabolic asymptote. So in this case for k, you're going to need to use limit properties in order to get the correct limit.